Good morning, myself Amrita Yadav, Senior Assistant Professor BP202. Today we will discuss about inductive effect and electromeric effect. Before starting electromeric effect and inductive effect, we will discuss some important terms. First, nucleophile. What is nucleophile? A reagent that brings an electron pair is called as nucleophile, that is, it is nucleus loving or nucleus seeking, and the reaction is known as nucleophilic reactions. Electrophile, a reagent that takes away an electron pair is called electrophile, that is electron seeking, or the reaction is called electrophilic reactions. Now coming to the homolytic cleavage and heterolytic cleavage, there are two types of cleavage in the organic reactions. One is homolytic cleavage. In homolytic cleavage, one of the electrons of the shared pair in a covalent bond goes with each of the bonded atoms, that is equal sharing of electrons occurs in homolytic cleavage. Thus, in homolytic cleavage, the movement of a single electron takes place instead of an electron pair, that is, one of the electron moves in one atom and other one is to the other atom. The single electron movement is shown by half-headed or fish-hook curve. Such cleavage result in the formation of neutral species, atom or groups which contains an unpaired electrons. Now these species are called as free radicals. Heterolytic cleavage. In heterolytic cleavage, the bond breaks in such a way that the shared pair of electrons remains with one of the atom. After electrolysis, one atom has a sextet electronic structure and have a positive charge on it, and the other is valence object with at least one lone pair with negative charge. For example, here we can see that bromomethane, cleavage of heterolytic cleavage of bromomethane, which will result in the formation of methyl ion and bromide ion. Here the electronegativity of bromine is greater than carbon, so the electron pair shift to the bromine atom, resulting in the formation of methyl ion and electron movement in organic reactions. The movement of electrons in organic reactions can be shown by curved arrow notations. It shows how changes in bonding occurs during electronic redistribution of electrons during the reactions. It means how a bond is break and how a electron redistribute themselves in a reaction. To show the change in position of a pair of electrons, curved arrow starts from the point from where an electron pair is shifted and it ends at a location to which the pair of electron may move. Giving to the example, shifting of electron pair is given below. You can see that in one figure there is a shifting from pi bond to adjacent bond position, resulting in the double bond formation. In second, it is the movement from the pi bond to adjacent atom, and in the third, the movement from the atom to the adjacent bond formation occurs. Now starting with the inductive effect. When a covalent bond is formed between atoms of different electronegativity, means there is a difference in electronegativity of two atoms. The electron density is more towards the more electronegative atom of the bond. Then such a shift of electron density result in a polar covalent bond. Bond polarity leads to various electronic effects in organic compounds. Let us consider the example of chloroethane, in which the CCl bond is a polar covalent bond. It is polarized in such a way that the carbon, you can see in the figure, carbon 1 gains some positive charge and the chlorine have negative charge. This is because the electronegativity of chlorine is more than the carbon atom. The fractional electronic charges of the two atoms in a polar covalent bond are denoted shift of electron density is shown by the arrow that points from delta positive to delta negative of the bond. In turn, we can see that in carbon 1, which has developed partial positive charge delta plus, draws some electron towards it from the adjacent carbon CC bond. Consequently, some positive charge develops on carbon 2 also, where delta plus symbolizes relatively smaller positive charge as compared to that on carbon 1. In other words, the polar carbon-chlorine bond induces polarity in the adjacent bond. Such polarization of sigma bond caused by the polarization of an adjacent sigma bond is known as the inductive effect. Inductive effect is passed on the subsequent bond also, but the effect decreases rapidly as the number of intervening bonds or the distance increases and becomes vanishingly small after 3 bonds. The inductive effect is related to the ability of subsequent to either withdraw or donate electron density to the attached carbon atom. Based on this ability, the subsequent can be classified as electron withdrawing groups or electron donating groups relative to hydrogen. Examples of electron withdrawing groups are halogens or many other groups such as nitrogen, cyano, carboxyl, ester, aryloxyl, etc. Whereas the alkyl groups like methyl, ethyl are usually considered as electron donating. Coming to the electromeric effect, it is a temporary effect. The organic compounds having a multiple bond, that is double or triple, show this effect in the presence of an attacking reagent only. It means electromeric effect affects in the presence of attacking reagent only. It is defined as complete transfer of shared pair of pi electrons to one of the atoms which is joined by multiple bond in the presence of attacking reagent. The effect is nullified or annulled as soon as the attacking reagent is removed from the reaction. That's why it is known as it is a temporary effect. It effects persist only in the presence of attacking reagent. It is represented by capital E and the shifting of electrons is shown by the curved arrow. Now coming to the types of electromeric effect. There are two types of electromeric effect. One is positive electromeric effect, another one is negative electromeric effect. Positive electromeric effect, in this effect, the high electrons of the multiple bond are transferred to that atom to which reagent get attached. For example, we can see in the C double bond C, in the presence of attacking reagent hydrogen ion, one of the atoms shifted to the carbon 1, which creates negative charge, and other one is positive charge, to which hydrogen or proton ion gets attached on the negative charge. Negative electromeric effect or minus E effect. In this effect, the pi electrons of the multiple bond are transferred to that atom to which attacking reagent does not get attached. For example, we can see that carbon double bond carbon, in presence of attacking reagent, that is cyanide, there is carbon double bond carbon, there is a shifting of pi electrons. One of the carbon gets delta negative and the other one is get delta positive. The cyanide ion or the attacking reagent attaches itself to the delta positive ion.